Today we are going to be taking a look at graphing quadratic functions in Vertex form. So the first thing is we've been dealing with quadratics, so hopefully we understand that a quadratic is a function that can be written in the form y equals ax squared plus bx plus c. Okay, where a can't be 0 because if a is 0, then the x squared goes away and it's no longer a quadratic. When we graph a quadratic function, we get a U-shaped graph that we call a parabola. Okay, that parabola can be opening up like a U or it can sort of be upside down like a hill, but either way, that U shape that we get is called a parabola. We can see an example of what this looks like if we start with our very basic quadratic. We call this the parent function, y equals x squared. And that parent function is where there's nothing being added or subtracted. It is as simple as it gets. So our a value is 1, there's nothing being added, there's nothing being subtracted. And so if we go to graph this, we don't know anything about graphing a parabola, so we have to fall back on our very, very old skills that we learned all the way back in trimester 1 about functions. Okay, and we said that we can graph any function if we plug in input and output values. And we did this a lot in first trimester. We even did problems just like this. Right? We can pick any values that we want for x, and we can get corresponding output values for y. So we could literally guess whatever input values that we want, but I'm going to give you 5 specific input values that we are going to pick. And we are going to pick -2, -1, 0, 1, and 2. And if we remember from way back when, right, when we wanted to find its corresponding output value, we would simply take this number and we would plug it in for x. So instead of saying y equals x squared, right, y now equals -2 squared. And -2 squared is a +4. Remember, we have to have that -2 in parentheses, so if you're using your calculator, make sure that is in parentheses. And then we'll just go down the list. So now we're going to do -1 squared, which is +1. We will do 0 squared, which is just 0. 1 squared, which is 1, and 2 squared, which is 4. Once we identified those values in our table, we then learned that those values actually make ordered pairs. So we now know that this is the ordered pair, -2, 4. So we can plot on our coordinate plane that we have right here, we can plot the point -2, +4. Remember, when we are plotting a point, our first coordinate is our x movement, our x and y, right? This is our x value. It goes on our x-axis, and then our second value is our vertical movement or our y-axis movement. Okay, next I'm going to plot the point -1, +1. I'm going to plot the point 0, 0, which is just our origin right there in the middle. 1, 1. And 2, 4. Just like we learned when we were doing linear functions, right? That line didn't just end wherever we made the points. It wasn't just connecting the dots. This was a graph that would continue to go, right? Because we could plug in more points over here, right? If we were to plug in 3, we would get an output of 9. So there'd still be a point 3, 9 on the graph. And there'd still be a point -3, 9. So that graph continues growing. So we don't want to just connect the dots. We want to know that this is a graph that continues going up in both directions. Like we said, it's a U-shaped graph, so it's curved. It's not coming down to a point like a V. This is a U shape. Okay, and this is what our parabolas look like. Now, every parabola has certain parts of it. So one of the parts of a parabola that we have is an axis of symmetry. An axis of symmetry is the line that's going to divide the parabola into 2 matching halves. So if I were to split this parabola right down the middle, my right side is mirroring the left side. It's a mirror image of it. That's what an axis of symmetry does. Okay, a parabola also has what we call a vertex. The vertex is going to be the high or the low point on a parabola. So if we look at this parabola up here, our low point that we have right here is here. So this is our vertex. If our A value is greater than 0, so numbers that are greater than 0 are going to be positive numbers, then the graph is going to open up like a U, and the graph will have a low point, which we call a minimum. If our A value is less than 0, numbers less than 0 are negative numbers, then the graph is going to open down, and the graph will have a maximum. So instead of being shaped like this parabola, which opens up, that's when A is positive, it's going to open down and sort of be an upside down version of that. So knowing those parts, we can then identify them just given an equation. Just like when we're given a linear function, y equals mx plus b, the m represents the slope and the b represents the y-intercept. There are now values inside a quadratic equation that tell us what the vertex is and what the axis of symmetry is, and if it opens up or if it opens down. So we can identify all of those pieces based on the function. So today we're going to be looking at quadratics in vertex form. So notice this form doesn't look exactly the same as this form. We are going to talk about it within this unit that we can go in between the two. But for right now, just like we can have slope-intercept form, point-slope form, standard form, we have the same idea that happens with quadratics. This particular form is called vertex form, where if we want to find the line of symmetry or the axis of symmetry, those two words mean the same thing, we are going to use x equals h. So we would identify what the h value is, and we would say x equals h, and that would tell us the line of symmetry. The line of symmetry, the axis of symmetry is a line, which is why it has that x equals. It is a vertical line. The vertex, we are going to identify by finding h and k. Right? A vertex is a point, which is an ordered pair, so it's going to have two different numbers in it. One particular thing of note that's really important is notice that the h value in this function has a negative in front of it. Okay, and that the k value has an addition in front of it, has a positive in front of it. Okay, that's going to be important here in just a minute. That h value, okay, the number that's sitting inside of the parentheses, is going to change our horizontal, h horizontal, movement. So that means how much the graph moves right and left. If h is positive, we are going to move right. And if h is negative, we are going to move left. Hey, k is going to change the vertical movement of the graph. So it's going to change how much the graph moves up and down. If k is positive, we are going to move up. And if k is negative, we are going to move down. All of those things overall make sense, right? Positive is right, negative is left, that's all fine. The one piece that's really tricky in here is that our h value is actually negative in the formula. We've seen this before in point-slope form, and what that actually tells us is that when we identify the h value for our horizontal right or left movement, we actually are gonna have to take the opposite sign of it. So just for h, we're actually taking the opposite sign of what it looks like. And the reason why is because that negative sign is already in the formula. We did the exact same thing in point-slope form. When it looked negative, we made it positive. Not because it was just fun, but because that's what the formula told us to do. So if we are given the function y equals x minus 4 squared plus 2, the first thing that we should identify or notice, I guess, is that this is in vertex form. It looks like this: y equals a times x minus h squared plus k. Looks like that format. So we can identify 3 important values from this function. We can identify an a value, we can identify an h value, and we can identify a k value. Notice that these letters are different than the letters we've seen in the past. In the past, we've seen A, B, and C. That A, B, and C is true when we are in this format. We call that standard form. We are not in that format. We are in vertex form. So the 3 letters that we can identify are A, H, and K. A is always the number sitting in front of the parentheses, right? The A falls in front of the parentheses. So we are going to look at this function and we are going to ask ourselves what number is sitting in front of the parentheses. We don't see one at all, but right when we don't see a number in the math world and it's through multiplication, we know that that value is really a 1. So we know that our A value is going to be a 1. Our H value is always the number sitting inside the parentheses, right? In our formula, H is the number inside the parentheses. So we want our number inside the parentheses, and we said we need to take the opposite sign of what it looks like. So if we look at this, this looks like a -4, but we are going to write this as a +4. So we know that our H value is going to be +4. It looks like a negative. We're writing it as a positive. We are taking the opposite sign. Then we are going to look at our K value. Okay, our K value is the number sitting at the end outside of the parentheses. And our K value stays the same. So our K value looks like a +2. So it is going to stay as a +2. So A is 1, H is 4, K is 2. We can now use all of those important letters to identify the important pieces. So our vertex, we said, would be H, K. Right? We said our vertex over here is always H, K. So we want to take the H value and we want to take the K value, and we are going to say that our vertex is now 4, 2 because it is H, K. Our axis of symmetry. Right, if we look over here in our notes, we said our axis of symmetry is X equals H. Our axis of symmetry and our line of symmetry, remember, are the exact same thing. So our axis of symmetry, if it's X equals H, is going to be X equals. You have to write the X equals. This is a line, not just a number. So X equals 2. The direction our parabola is going to open is going to be based on the A value. If we look over here in our notes, we said if A is greater than 0, if A is positive, it's going to open up. And if A is negative, it is going to open down. So the direction for this parabola, A is +1. So we know that this parabola is going to open up. This gives us enough information to graph our parabola. Believe it or not, that's all we need. So what we are going to do is we are going to start by plotting our vertex. We said our vertex is the point 4, 2. Now, if we remember, we said that our H and our K are just shifting a quadratic, a parabola, right and left and up and down. So what it did is it shifted a parabola over 4, right 4, and up 2. The parabola that it's shifting is this original parabola that we started with. So we want to mimic this exact same parabola except instead of it now having a vertex at the point 0, 0, we want it to now have a vertex at the point 4, 2. So if we look at how this next point falls, this next point is over 1, up 1. So the next point that we want to do is from this vertex, over 1, up 1. Okay, there's another point that goes over left, up 1. So from here, I'm going to go over left, up 1. Okay, then I'm going to check and see where my other point falls. It's over 2, up 4. So from my vertex, not from the points I just made, but from my vertex, I'm going to go over 2, up 4. And then my last point is the same thing. It's left 2, up 4. So from here, I'm going to go left 2, up 4. And this is our parabola. Now, if we make a note, those points that we just did were left 2, up 4. Left 1, up 1. Right 1, up 1. Right 2, up 4. You should notice those look very similar to the points that we had here. Okay, and those are the same movement points we will use every single time. Why? Because going over 1, 1 squared is 1. Going over 2, 2 squared is 4. If we were to go over 3, 3 squared is 9. So we'd go up 9. The last piece that we are going to do is we are going to identify a point and a symmetric point. We do that by identifying 2 points that if we were to fold the parabola in half, they would fall on top of each other. So for example, these 2 points are symmetric points because if we were to fold this on top of each other, they'd fall on top of each other. So I could name this point as the point 1, 2, 3, 1, 2, 3. I'm just naming it by counting where it falls in the coordinate plane. Nothing fancy. And this point right here I'm going to name as the point 5, 3. There's no rule that says one of those points has to be first. So if you listed 5, 3 first and 3, 3 second, that would be absolutely fine. It would also be completely fine if you happen to pick this point and this point, because those are symmetric points as well. So it'd be equally fair if you said 2, 1, 2, 3, 4, 5, 6, 2, 6, 2, 3, 4, 5, 6, and 6, 6. You don't have to label both, but if you put either set, that would count as a point and a symmetric point. We're going to look at one final example. Y equals negative, and then in parentheses, x plus 2 squared minus 3. So we're going to start this the same way. We are going to identify our A, our H, and our K. So our A value is -1 because it's what's in front of the parentheses. Our H value is what's inside the parentheses. So remember, we take the opposite of H. This looks like a +2, which means we are going to write it as a -2. Our K value is -3. Our K value stays the same, so it looks like a -3, so it stays a -3. We will use that information to now fill in the rest of our info down here. Our vertex is always H, K, so our vertex is going to be -2, -3. Our axis of symmetry is always x equals h. So in this case, it'll be x equals, our h value is -2. This parabola has an a value that's negative, so this parabola is going to open down. So not up, but down. So ours is going to look like a hill instead of like a bowl. Okay, so that gives us enough information to start graphing. So we're going to plot the ordered pair, -2, -3. I'm just plotting that vertex. I want to follow those exact same patterns of how I make the other points. The only difference is I want this parabola to open down. So instead of going right 1 and up 1, I'm going to go right 1 and down 1. Okay, that happens on both sides of the parabola. Why? Because when I go over 1, 1 squared is 1, and this tells me to open down. I'm going to go back to my vertex, not the points I made, but back to my vertex. I'm going to go over 2 and down 4. Why? Because 2 squared is 4. I'm going to do that on both sides because it's symmetric. And here is my parabola. So now I can name a point and a symmetric point. Again, I have a pick of which one, but I'm just gonna pick the two that are closer to the vertex. So I'm gonna pick this one right here. And so if I name this ordered pair, it is the ordered pair -1, 1, 2, 3, 4, -1, 4. And its symmetric point is going to be -1, 2, 3, 1, 2, 3, 4, -3. Oops, I forgot my negative on that one. -3, -4.